Lamia.
Who is? Okay, you are there from Morocco, and then the third one is Roa El Gothkeli, Shireen Mausan, handling faults in service-oriented computing. And I hope that Saida is also there. She has not joined yet. Okay, so let us start and welcome to our workshop chair to Beniamino. You are welcome in my workshop. Beniamino,
Hi, Sanjay. Nice to meet you.
how are you?
Fine, fine.
Nice to see you. I was missing you. Very hectic,
I don't,
schedule.
unfortunately, I haven't the time in these few days to go to your session. I have 5 minutes and I
So
just
my
to
name,
say welcome to you.
my name is and this work is about the effect of phase change during the deposition stage in fused filament fabrication. This is the outline of my presentation, so I will start with the motivation. Fused deposition, fused filament fabrication is a rapid prototype.
Please, first, I request to all those audience, please unmute your mic, okay? Please, there is a lot of background noise. Please, all the audience, please.
The presenter, unmute yourself. Perfect.
Yes, perfect. Unmute everybody, please. Emine, please come and share your slide.
I'm sharing right now.
Yes,
Perfect.
yeah, you are welcome.
Could you see my
Yeah, we can see it.
PowerPoint? Okay, I am
Yes,
starting.
yes. You are welcome.
Thank you. And hello, everybody. My name is Emine. I am a PhD student at Yıldız Technical University. Today, I will talk about my paper, which title is Test Case Generation Framework for Client-Server Applications. In this study, we have used reverse engineering approach. This is my presentation outline. Firstly, I will give a brief introduction regarding our motivation for this studying. After, I will talk about background regarding targeting system and use data. And next, I will explain our proposed framework, which is message-driven test case generation framework. And then next, I will give an empirical case study. Finally, I will talk about conclusion and our future work. Testing can be implemented. We know testing can be implemented either manually or automatically. And especially in companies using incremental model, the software should be developed incrementally, and new requirements at each increment necessitate change in the software. Thus, testers should verify the new function as soon as possible. But accomplishing this manually is very difficult in medium-sized or large-sized business software systems, because such systems can contain hundreds of business functions, and it is difficult to do manual API testing repeatedly, because manual testing is very time-consuming, error-prone, and tedious. We know automation solves these problems. So in this study, we decided to automate the manual API regression testing process for the system based on client-server architecture. So to be able to do this, we divided our studying into the three parts. The first part is automatically test case generation. So in this context, we have developed a framework, which is message-driven test case generation framework. Our proposed framework basically generates test cases from captured network packets between client-server communications over networks. We propose a novel approach to record packets for regression testing. Our approach uses information at the packet level and produces test cases automatically. And the second part is automatically test execution of created test cases. And the last one is validation and defect reporting. Today, I will show how we generate test cases automatically. And this is our proposed targeting system architecture. There can be many client applications connect to the server application on the predefined ports. There is no graphical user interface for the targeting server application. Communication between client and server side is established by using TCP or UDP data packets. And each data packet has header section and payload section. The header section contains some information like source port, destination port, and the payload section, this is the data section, contains data, I mean API messages carried for the applications. Packets between client and server are captured in a PCAP file. PCAP means packet capture. Each PCAP in the PCAP file displays the communication data packets, including API messages between client and server applications. And our studying is motivated by the lack of regression test automation framework in a specific domain, which is client-server applications, which uses API messages for the communication, such as banking application, trading system in the stock exchange. I can say because the existing API testing tools are mostly for web APIs. I have done some research, and existing API testing tools are mostly for web APIs, which can be accessed using HTTP protocol. Especially REST APIs are mostly used, and basically they use JSON or XML formats to deliver REST API responses. So the other system structure for the other application layer protocols, we have proposed a novel approach. And for these purposes, the message-driven test case generation framework is developed. The input file to the framework is a PCAP file. This file is analyzed, and reverse engineering is used to determine values sent back and forth between the server and the client. Basically, the framework reads the PCAP file and produces test suites. Each test case in the test suite contains both messages sent by the client and the responding messages sent by the server to the client. Firstly, when the time data packet in the PCAP file is read, the framework starts to analyze the packet. Initially, it detects which transport layer protocol, TCP or UDP, were used in the communication. If TCP is used, the framework analyzes the packet to determine whether or not the packet is retransmitted. If we detect this packet is retransmitted, we ignore it because the original version of the packet is already stored in the test cases. And after detecting communication protocol, heuristic search techniques are applied to detect which application layer protocol are used. The determined message patterns according to the targeting system are searched in the payload section of the packet. And finally, the payload section is parsed according to the predefined messaging format of the software system in question. And finally, the final obtained packet is mapped to understand whether the packet is a client message, which is a request message sent by the client to the server, or a server message, which is a response message sent by the server to the client. And given the previous discussion, our basic algorithm should now be easy to follow. And this algorithm describes the main create test suite routine that loops until the end of PCAP file, making a call to get next packet in the file once per iteration. After extracting packet details like arrival time, source destination IP endpoint, and use protocol as a transmission protocol TCP or UDP, by calling extract packet detail method in line 4, it makes a call to construct messages in the packet, to create messages in the packet according to the predefined messaging format of the targeting software system. And finally, we add the created messages, previous created messages to the test suite by mapping as request or response messages in line in line 5. And we have conducted a set of empirical studies to evaluate the usability of the framework and applied it to the trading system in the Borsa Istanbul Stock Exchange, which is a trading company in Istanbul. In this case study, we have used test suite pkep file, and this file contains both fixed API messages, API protocol messages, and Arch API protocol messages. Fix is the standard protocol for exchange within the finance world, and the Arch protocol is composed of logical messages passed between the Arch host and the client application. I can say these two protocols have completely different message structure, and these are application layer protocols. And this is a screenshot of the Wireshark tool. This is packet analyzer tool. It shows the content of pkep file. It contains both fixed and Arch protocol messages, and we use this file as an input, and the developer framework absorbs this file and produces separate test suites for each different for each separate protocols. And this is the first created test suite for Arch API protocol. 8 test cases are selected to show. For example, when a tester deals with test case 1, if a login request packet with the specified data within the table is sent to the server, the login accept packet is received as a response. And this is another test suite. It illustrates the selected test cases produced from test suite pkep file for the fixed API protocol. As a summary, our proposed approach records packets for regression testing and produces test cases at packet level automatically. It supports the reuse of test cases, and it will increase automation in software testing, improves efficiency, and speed up release cycle. It reports a significant reuse capability and reduction of effort on a real-world financial system example. As the future work, we will implement replay part and validation and defect reporting part. To be able to do this, we will determine validation methods. Thank you for your attention.
Thank you so much.
Thank you.
Have you any questions, please? There are several guys from the software engineering here sitting here. So please ask question and encourage to the presenter from Istanbul Technical University. I think, Imine, you have already been here last years, right?
Sorry?
I think you have submitted your papers last years as well.
Yes.
But you have not presented physically any time.
Yes, yes.
Yes, please. Any question?
Any question?
Yeah, from my side, okay. Can you summarize in 1 or 2 lines that what is the major contribution what you did in this paper?
Our approach uses information at the packet level and produces test cases automatically. And I mean, the idea here is to capture the usage data at packet level to ensure they are more application independent. Actually, this process is the easiest method to obtain different requests from various clients. It will ensure 100% automation in a software testing, from test case creation to execution for API testing. And I have said it supports the reuse of the test cases, and that's all.
Okay, no, I just want, I am wondering that in 2011-12, I also did the automation of the test case, means we are prioritizing all those requirements, and then from the use cases, we transform into a form of a tool. I did it in 11-12, right? So we are prioritizing all those requirements and other things. And when I see your paper, in fact, I have not gone into the depth of your paper, but I am wondering that what additional things you are doing, because testing process is going to be automated. It is since a long time, you understand. So what exactly new things for example, for example, myself, I added some from the activity diagram. We are taking the best, which is the most, which is the most important, or the prioritized requirements are there. We try to add it. So exactly in the same way, I wanted you that just to means give one or two very novel things what you are going to add in the means.
Okay, I see. I can say that there are different techniques to be able to create test
Yeah,
case
hello,
generation.
yes.
Yes, yes. But I have said that it is more application independence in applying our approach to your any target, any system. And I can say that in many cases the input messages to an API call depends on the response messages obtained from other API calls. I know existing API testing tools does not support extracting input from responses, hence not provide 100% automation. In this approach, we will parse response messages coming from the server and use it for the next input messages when specifying input data. So we will increase the automation and sorry.
It's okay. It's okay. It's okay. I understand. Thank you so much.
We will ensure the end-to-end automation by applying future work.
Okay. It's okay. So thank you so much. It was a nice presentation, and I hope that the guys enjoyed, the audience enjoyed. Now I will like to invite to the second presenter. I think Lamai Sardi, right, from Morocco. Yeah, we are waiting for you to listen. You are welcome. Okay, please share your Lamai Sardi. Please share your screen. Unmute your microphone. Yes, please start.
Tamam, ben de şey dedim, pek çok teknik var, daha biz end-to-end automation sağlıyoruz.
We can't hear you. If you could unmute yourself, please, by clicking on the microphone icon at the bottom of your screen. Thank you.
Okay.
Perfect.
Okay. Okay, good afternoon, everyone. My name is Lamia Sabdi, and I'm from the University Mohammed V in Rabat, Morocco. I'm here to present my work entitled Gamified eHealth Solution to Promote Postnatal Care in Morocco. This work is part of a peer research project called Facilitating Reproductive Health Services for Refugee Women in Morocco that is financed by the USAID. The presentation is organized as follows. First, a brief introduction to postnatal care and its status in Morocco. Next, a comprehensive description of the proposed mobile solution. Then, a presentation of the experiment design of quality evaluation of the solution. Finally, a few highlights and future perspective will be provided to wrap up this presentation. The postnatal period is a very challenging phase of the lives of both mothers and newborns. It is commonly defined as the first week following childbirth, but it may last up to 6 months following delivery until the new mother regains her pre-pregnancy shape and heals completely. Given the inherent physiological, psycho-emotional, and social changes that occur during this period, an optimal care and a close attention is therefore necessary for both mother and newborn to sustain their good health and well-being. Subsequently, postnatal care should be provided throughout all this period. According to international guidelines on reproductive health, postnatal care covers integrated maternal newborn care practices. In that, vaginal care, targeted postpartum hygiene and nutrition, newborn care, and counseling on family planning and exclusive breastfeeding are the most prominent pillars of postnatal care. Despite this crucial importance of postnatal care in the lives of mothers and newborn, it consistently has the lowest coverage of intervention in maternal and infant care. In the whole Africa, and according to the World Health Organization, postnatal care programs are among the weakest of all reproductive and child health programs in Africa. In Morocco, the postnatal care is suboptimal, which subsequently contributes in maternal and infant mortality rates. Poor communication, lack of awareness and information, financial difficulties are among the most prevalent factors hampering the utilization of postnatal care services in the country. A potential intervention that could reduce some of these modifiable factors is the incorporation of Google. With the outstanding technological advancements, mobile health or mHealth has been proven to have tremendous appeal in that it promises significant improvement in quality, convenience, reach, and cost. In this regard, a significant attention has been drawn to leveraging mobile technologies in the promotion of reproductive healthcare, including contraception, pregnancy monitoring, and postnatal care. According to a recent review, most of postnatal care apps available in app repositories overlook mothers' need during the postnatal period as regards the postpartum weight monitoring, mental well-being support, and family planning. And albeit this significant number of apps that are available in the app repositories, the literature in this area is still very scarce. Hence, the aim of this work is to design and develop a comprehensive, gamified mobile health solution to promote postnatal care. The completeness of this solution consists of combining functional content that addresses newborn and maternal care along with the counseling sections and on all aspects underpinning the postnatal period. Mama and Baby is the name given to our proposed solution. It is a mobile application being currently developed under using an Android platform. It is a user-centered app intended to accompany new mothers during their postnatal period, to promote postnatal care through the provision of helpful tips and advices for postpartum recovery and recommendation and advice and recommendation on baby care. It also promises to alleviate the emotional burden that is correlated with the postnatal period by means of social interaction and counseling on mental well-being. Before diving in actual development, we have specified the main requirements to be included in the solution to attain its paramount objective. A software requirement specification document has been developed and elaborated using the ICCSA 1929-148 standard, and it has been validated by a clinical staff of gynecologists and nurses at Maternity Les Orangers in Rabat. So the requirements are divided into three categories: functional requirements, non-functional requirements, and gamification aspects. Due to time constraint, I'm only going to give you a few examples of these requirements. Among the functional requirements, excuse me, I cite the following. The user shall be able to track her baby growth and compare it to standard child growth percentiles. The user shall be able to track her newborn. For the non-functional requirements, Mama and Baby or the solution should cater users' need through well-integrated functions, useful and appropriate content. It should use a strong authentication mechanism. It should include a privacy policy that is detailed, comprehensive, and understandable. And before tackling the gamification requirements, let's first define the gamification. So the gamification is commonly defined as the use of game elements in non-game contexts. It is being employed in different fields such as education, marketing, industry, and health to foster and sustain users' long-term engagement and motivation, to promote healthy behavior, and to induce positive emotional states. Various game elements are being used in our solution, such as point-based scoring. For example, a user shall earn 15 points for filling the self-report measure for postpartum depression screening. It also includes the badges, leaderboard, and virtual goods. In this slide, you can see a few snapshots of user interfaces of our solution: the dashboard, a menu, medication management, postpartum weight monitoring or tracking, the PPD quiz or the postpartum depression quiz, and also an FAQ. So now that our solution is developed and tested by the clinical staff, we are planning to conduct an experiment with a real participant to assess the quality, effectiveness, and usefulness of the solution. This will happen under the close attention and supervision of the clinical staff at the maternity des Angers for Rabat. A total of 65 puerperal women will be part of this evaluation. These women have to be aged between 20 and 45 years old, resident in the region of Rabat. They have to own an Android smartphone and be pretty acquainted with mobile technologies. Regarding the evaluation procedures, all the participants will be initiated to the experiment and the solution. They will be asked to install the solution on their smartphone, and they will be also asked to complete a set of tasks throughout the 6 months of use in order to fill an assessment questionnaire by providing credible feedback on the overall quality of the solution. So we have three different questionnaire. The first one has been developed using the ISO 25010 model to assess the product quality of the solution, and it comprises 30 items. The second one has 13 items and has been elaborated using the same ISO 25010 model and the QGameSoft model to assess the quality in use of gamified software. And the final one is a set of 5 questions on a 100 scale to evaluate the potential of the solution in improving access to postnatal care. The results obtained from this evaluation will help us answer these research questions for a better improvement of our solution and a precise orientation of our research. To wrap up this presentation, let's go through the main highlight. Due to the scarcity of the literature in the area of postnatal care apps and the non-completeness of the available postnatal care apps, we have proposed the requirements specification of a gamified postnatal care mobile solution. And also, we have described the experiment design of the quality evaluation of this solution. As a future work, we intend to complete the implementation of the solution by integrating the gamification aspects. I didn't mention it earlier. The application is now fully complete in terms of functional and non-functional requirements, but the gamification requirements are we have planned to implement in the next version, inshallah. Also, we plan to conduct the empirical evaluation following the experiment design that I have described with real participants, and then we shall answer the research question previously mentioned based on the results obtained from the empirical evaluation study. Well, this is it. Thank you for your attention.
It is a nice presentation by Lamai. Please, questions?
Yeah.
Questions,
Okay.
please.
Here.
Questions, please. Professor Ali is from Morocco and he is working on this software engineering. Okay, for the non-functional requirement, you mentioned that you have already included the functional and non-functional requirement in your system, right?
Right, yeah.
Yeah. So have you also tested it anywhere?
Sorry?
Have you tested your application?
Yeah, sure. Yeah, we have tested it using like black box and units testing.
Hmm. Okay,
Yeah,
but
right.
you have not implemented in any real platform, right?
No, still not. No, still not yet.
Tested means what I mean by implementation.
Yeah, we
Uh,
just the software and the useful and the content also, like the medical content. It has been validated by the clinical staff, but
okay.
the quality and the usefulness of the app will be tested and validated in the empirical evaluation that we are planning to conduct very soon.
Usability and other quality attributes, you will do it in the future, right?
Right, because you know that the ISO 25010 model has like plenty of characteristics that can be tested and validated using this model with the real participants to in order to gain a credible and honest feedback on the solution.
So I'm waiting for your next work in the ICCA 21, right? Your empirical validation on the work. Okay. In all those audience, please wait. Her next presentations and the topic of the next presentation, empirical validation of non-functional requirement on the system, right?
Yeah, why
Okay.
not?
Giving you the topic of a paper. Right, good, very nice presentation. Any question, others? Any question from anybody? Jay, unmute your mic. Jay, unmute your mic.
Sorry. Yes, okay. Is the system working on an Android platform or proposed on an Android platform?
Yes.
Okay. Is there any plans for an iOS implementation as well?
For now, no, but we are planning to have a hybrid app that can work over cross-platform.
Oh, okay.
But for now, it is just Android, like it's fully fledged Android.
Okay, that sounds good. Looking forward. Thank you.
Thank
Okay.
you.
Thank you, Lamai. We see you next time, and I hope that you will enjoy the remaining conference as well. Okay, so stay with us up to the next session. The next presenter, I invite to the next presenter. This is the ROA. ROA is already in the room for handling the fault in service-oriented computing. ROA is there. Roa, next presenter.
She has an issue.
Roa,
She has an issue, like she wrote it on the chat thing.
She's just running the presentation now.
To connect, but apparently there is an issue with her connection.
Okay, and is anybody missing for the presentation from morning or somebody? Because the session was tight. Roa is already present. Saida is trying to come as early as possible, but she is also not there.
Hello, this is Saida Subul Hussain from Bangladesh.
Hello?
Hello.
Yes.
Sir, may I, I'm just come to know that my presentation is going on. For that, I'm very much sorry, but I couldn't make any presentation slide. Can I present my research for my paper? Am I allowed to do that?
present it because there is no any slot vacant. The authors are just
Sorry, sir.
you have not prepared your PPTs, right? Why?
Yes, yes, sir.
Mirna, Munoj is ready. Please, you can present. Mirna,
Okay. Yes.
please present. Saida, please prepare your PPTs as soon as possible.
Okay, sir.
Roa also, you have to be, means we can wait up to this 4:30 from this, 5:30 from here, because next session is full. Tomorrow is also full, so when we can give you the slide, I don't know. Roa is there. Please keep your name. Change your ISTI name. Change your ISTI
Okay.
name. Roa.
Did you see my
And
screen?
if possible, on your camera, so we can see and identify the authors as well. Yes. Mirna.
Yes.
Yes. In which your session is in SEPA what?
Sorry.
Yes, present it.
Okay. Okay. Did you see the complete presentation?
Mm-hmm.
Okay. So thank you very much for the opportunity, and I'm so sorry for for the inconvenience. I'm going to present the paper, A Path for the Implementation of Best Practices for Software Requirements Management Process using a Multimodal Environment. This is a work done by University of Medellin of Colombia and from CIMAC, Mathematical Research Center from Mexico. My name is Mirna Muñoz. And about the agenda, I'm going to start with an introduction, then I'm going to show you what was our research methodology. After, I'm going to show the results that are focused on a path for software requirement management. Finally, the conclusions. So first, the introduction. Nowadays, software industry expends high effort to implement models and standards such as MMI, ISO, 12207 or 15504. And what's happening that for the small and medium enterprises, they have really difficulties on implementing those models and standards because those standards are oriented to large organizations. So for them, it's very difficult to implement those standards because of cost, effort, and the return on investment that is not in short time. So, to implement software process improvement in this type of organizations represents a great investment, and they have difficulties to achieve the goal in short term, and sometimes with significant resources losses. So what we are proposing in this paper is to use multimodal environments. Why multimodal environments? Because it is considered that a multimodal environment provides a solution in the way that it allows harmonized and unified approach through the implementation of different models and standards. So it could give small and medium enterprises an unified single improvement plan. By this way, it allows to focus the improvement on the organization needs instead of focusing on the implementation of a complete model or standard. And it is a way to reduce the effort to implement a complete model or standard. So our objective is to provide a path that allows small and medium enterprises to follow it in order to facilitate the implementation of best practice and specific for this paper in the requirement management processes. So with this path, we are trying to provide an alternative to facilitate the process improvement using a multimodal environment in small and medium enterprises. So about our research methodology, we follow a design-oriented research methodology in which we have three main phases. About relevance, in this phase, what we did was to adapt a previous model, a previous method, named as Model and Standard Similarity Study method, and it was built by myself years ago. So we adapt this method in order to be able to select those models and standards that could be part of our multimodal environment. About the design, the second phase, what we did here was the strong work. We identified the best practices. We refine the mapping performed using the model and standard similarity method, and in order to we refine those that mapping, and then we be able to get the general scheme for the path that we are proposing, and I'm going to show you in next slides. And finally, about rigor, what we did in this step was to prove to find any way to prove our proposal. So in this case, we use the validation using or helping us by some experts in software process improvement, and that's the design-oriented research methodology that we use. It was very useful to use it. About the path, the first, as I mentioned, the first phase, the relevance cycle, we will be able to identify those models and standards that will be part of our multimodal environment. So following the rules or the recommendation of the model and standard similarity study method, we establish a baseline in order to determine the similarity of the models and standards in a practice level, that is the lower level of the CMMI that we took as the reference model. Then we define a correspondence template that could help us to register inputs to practice and work products of models and standards that we select to be part of our multimodal environment. Next, we establish a nomenclature in order to identify those elements from which model and standards were. And finally, we consolidate the results, identifying how to those elements could be evaluated. And really, what we are trying to find is that those elements included in the multimodal environment really complement our reference models, and in this case was CMMI. So this is an example of what we did following the model and standard similarity method. So as you can see, this table shows our first mapping. The mapping was done by the specific practice established requirements for the product and process components. As you can see, these elements has a nomenclature that help us to identify from which model and standards they are. And with this mapping, we built a first path. This is the primary path. But what we trying to do is to establish a path that help the implementation, in this case, of the requirement management. So what we did was to develop or to establish 2 criteria in order to analyze our first results mapping. Yes. So we apply 2 criteria, and if we have identified a direct relation between or among the practice, it will be part of the main or the primary implementation part, and if not, we just take off the practice. So this table shows how was done the consolidation of the results. So if you can see, these are listed the practices, and we have analyzed all the elements provided by the reference and the reference model and standards. And if it is yes, it's add 1 point, and if it's not, we just don't take into account those practices. So applying, or as I mentioned, applying our criteria, we decide which of these practices will be part of the main part, of the primary part. So in order to provide to the small and medium enterprises useful material, what we did was this type of diagram that we include in the first quadrant. We include the practice that the organization should implement. In the second quadrant, we add or provide, this is a practice, but the second quadrant provides the list of activities that the organization should implement. On the third quadrant, we provide the tools that could help to implement the activities in a better way. And finally, the last quadrant, we provide the outputs that that the organization should get in doing this practice. So this is the material we provide we will provide to the organizations. And a complementary material is a flow diagram in which we summarize the activities and to indicate in which step they should obtain some specific work products. About the how we validate our proposal, we, as I mentioned, we will help by a group of software engineering experts in software process improvement. So we got some recommendations from them. For example, that required management is right. It is a starting point for the implementation of software improvement because it is a process that must be followed in order to ensure an early quality. And as they corroborate that some specific practice that we have in the primary part are critical for the process, for implementation of the process, and that the indirect relationships we take care, because the indirect relationships could be relevant either for the process improvement. About that, we were doing in a right way the selection of complementary practices of other model and standards in order to reinforce the CMMI, because we took it as a base model. And finally, about research limitation. The experience and the subjective of the experts in the study area, we try to reduce this limitation by selecting the researchers with more experience or try to find researchers that work in our group and with more experience in software process improvement. we know that we are preparing some case studies in order to prove it in a real environment that is trying to achieve the implementation of this path in a real organizations. We are working on that. So as a conclusion, we present a guide for the implementation of best practice. We achieved to build a guide for that allows small and medium enterprises to implement the requirement process management. The implementation part describes different charts, such as linear diagram.
Summarize your work. Please summarize your work, okay?
Okay.
Come on, conclusion. Nobody can see your slides. Your slides is with you.
Oh, sorry.
It's okay, no problem. Come on, conclusion, okay? We are hearing, yes. Now we can see.
Sorry. Okay, just that we try to we will working on to be able to implement a real case study in which we could prove the useful of this path, but according to the feedback received by the expert, we think we are doing the right in the right way. So as future work, just that we are designing a case study for implement it in a real environment, and we are trying to perform or to build other paths related to other processes such as project management and verification and validation. Some processes that we have analyzed, they have problems. Organizations have problems to use engineering practice on it. And that's all. Thank you very much for the opportunity to present.
Thank you. Any question, please? Any question, please?
Hello, Prof. I have a question.
Yes, please ask. Go ahead.
How will this be applied in an agile environment?
Sorry, again, please.
How will your research work be applied in an agile environment?
Okay, so this is a very interesting question. Thank you very much. We think that we could give some values to the primary path in order to highlight or to prioritize which practice are essential and could be implemented in an agile environment. The problem here is that it is based on CMMI, and it's more a robust model. But I think it could be done, but just taking off some of the primary, some of the best practice included in the primary. I think it could be, but we need to do some specific modifications in order to give some values or some evaluation to the primary part practices in order to be liked, to be implemented in an agile environment.
Thank you very much. Thank you. Thank you, Prof.
Thank you.
Any other question, please? Yes. So Roa is ready now for the next presentation. Thank you.
Thank you very much.
Thank you, Mirna. Thank you. Okay. Is the Mirna available? Mirna. Okay, sorry. Roa is available. Roa, whose presentation was the previous one. Is Saida available? Because it is within 3 minutes. We are going to start our next sessions. And I can see the authors are already present, right? Saida.
Can you present now, sir?
Saida, yes, you can present now.
Okay.
Share your screen, please.
Is it coming, sir?
Yes, it's okay.
Okay.
Go ahead.
So, okay. This is an empirical study on requirements reusability. So one of our prepared work is done on a survey study on the requirements reusability in distributed large-scale agile projects. As far as the same, we have done an systematic mapping study in this same topic to find out the current state of the art in this topic. So the keywords we have selected here: requirements reusability. That means we can reuse any sort of software artifacts in our from any previous or any identical projects. And the next one is agile. We all know about the agile methodology and the distributed software development. Sometimes nowadays it becomes same. Real life scenario practice. That means we work together in a distributed nature in our dispersed team or sometimes in this distributed team. And the large scale, when we implement any software or build, we are going to build any software in huge manner, that becomes a large scale software development. And global software development is also represents the distributed nature of software development. And the methodology we have followed here is the systematic mapping study. So to perform this study, we have designed our research question just like what are the requirements, reusability challenges, and mitigation techniques in distributed large-scale agile projects reported in the up to the minutes. So for searching this question or to moving forward to the result of this question, we have designed our overall research methodology just like in 5 steps. And first one is defining research question. After defining the research question, we have sorted out the studies by doing the execution of search query. We have in this, we can see here, we have formed our search string. Just like here, we have presented 2 search string, and we have defined 5 important scientific database from where we have done our search process. And the second is after searching the results, we have found too many results, and after that we have formulated our inclusion and exclusion criteria. For that, we have selected some keywords, then title, abstract, index terms to perform the inclusion exclusion process. And after that, we have accepted the overall gist from that papers, and we have sorted our papers in 2 parts. The first one is challenges with current state of art and the mitigation approaches by the practitioners. And this is the overall result. I'm not going to show the result, just like I'm just concluding here, just like saying 2 things, that we have pointed out 84 challenges and 43 mitigation techniques in terms of communication, collaboration, and control. Our main focus was in that we have decomposed our problems and mitigation techniques in these 3 C's. And I have attached here there is sorry. There is 2 table in my paper. I couldn't bring here as this was too long. So I want to show you from that here that we have sorted our challenges processing in 3 categories, and same as for the mitigations. And that's all for my presentation, and I'm very much sorry for this type of unprepared presentation.
No, my simple question is that why you are not prepared?
Sir, I was a lecturer in Daffodil International University. I think I got very much time to perform, because this is not the excuse. I must be prepared.
No,
but I'm
because
not.
you were thinking
But
that presentation is not important. I think the
due to the
concept in your
pandemic
mind was
situation,
that I think that the concept in your mind was that presentation is not important. Like last year's, just to publish the paper
right,
and
right,
it's all.
sir,
But
right, sir.
it is also, and but you are showing something from your old paper. So what is the basic difference? Why you are showing us the old paper? Is it something is
Okay.
taken from there to here? Because it is already published paper. And I think it is also in ICCSA, right?
Yes, sir. No, no, it's not the ICCSA.
So in
This one is
any
yes.
other
Any other?
springer,
Yes, sir.
in
Yes,
other
sir.
springer conference. So how means my question is at this time
Okay.
that with same questionnaire or same study, how many SLR you are going to publish?
How many SLR I'm going to publish?
Yes, of course, yeah. It is your second paper, right? On the same, on the same
Yes,
study.
yes, 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 yes. On the same study, yes, sir. Yes, because why I am service study too many practitioners, I found some mismatches. So from there, I want to do some elaborate work on the systematic mapping study. In that study, in my survey, the prior work, there is always also some indecisions, and there are some mismatch is presented there also.
So
But I
show
am doing
those. Okay, right,
yes, sir.
right, right. So show those mismatches in your presentation. Tell us that what was those mismatches. What you did, it was not acceptable by practitioners. What you have modified it. This is presented in this paper. Show them. Tell us. We will hear you. That's why we are here. You are saying that there was something problem what you published last time. So practitioners has raised some issues. Some there was mismatching. So what was those mismatching and how you identified and how you have improved that one and you presented
Yes,
in
sir.
this paper.
This is the elaboration work of my systematic mapping study, but I am going to do the find out the mismatches, what the practitioners actually faces, and what the literature is stated. So I will work on later on the next on any kind of paper like that. That what we have just stated in any literature is not the true actually.
No, but you are not pointing the points. You are telling general things, but you are not identifying what are those points. What are those mismatches?
Oh, okay, sir. I am not showing here in this paper any mismatches, but I am just seeing all the important things in terms of communication control and collaboration for the mitigation techniques and the challenges faced by the practitioners, which are stated in current state of art. Sir.
These are the well-known challenges in GSD. These are well-known challenges. Our research approximately 20 years when we have started the GSD platform or something. It's okay. Anyway, you have presented. Thank you very much. I'm sorry that I disturb you since I send you several mails. I don't know. I don't like that it is means I'm sending the emails only then authors are wake up that okay, am I to present? Why? It's okay. Thank you so much, Saida, for joining to the ICCSA. I hope that your mismatches we will see in the ICCA 21, right? I will
Okay,
see.
we'll see, sir. Inshallah.
Maybe we will see that your mismatches and more study on that matter with some concrete, solid evidences and some new results that okay, what you did it in the last, what is your addition in this one, and what will be in the next one. We will see in the next year. Thank you so much for all
Okay.
the authors and all the presenters for the sessions. I think, can you on the camera? All the camera, if you on your cam, so I can take a picture from here. Everybody, please on the cam. Please on your cam. It's still less than half. Please, if you are hearing me, please on the cam. Yes, I can see my friends as well, right? Michael, Lamai is also there. Very nice to see.
Hi,
Yeah, we can't see you.
can you see me?
Yes, yes, I can see you, Michael. You are one of the most smart personality at this time. Yes, thank you. We took it. Saida, you are absent. Why? She has gone. It's okay. Thank you so much. So we are moving to the next session. Say ISSQ 3, right? And I think Peter is present. Is Peter present? Peter is present, yes. Peter is present. So can you take the session? Can you start, Peter? Can you hear me, Peter? Peter, unmute your mic. Peter is available.
I'm trying
Moderator,
to
please help
contact
me.
him
I don't
by
know.
private
Peter
message
is there.
to see. Okay, I see
Okay.
he set his microphone on. Okay,
Okay,
here we
hello.
go. Hello?
Sorry,
Yes,
I'm here.
Peter, please.
Okay,
Yeah, we are
should
calling
I?
you. I think start it.
Okay, okay, I will start. Okay, just a moment. Okay, do you see it?
Yes, yes, please go ahead. Some problem with the Peter
Okay, I'm
internet
here.
connection?
Sorry.
Okay.
Do you see my presentation?
Yes, yes, yes,
Okay.
please go ahead.
So, okay, I would like to present my work that got the title Inspecting JavaScript Vulnerability Mitigation Patches with Automated Fix Generation in mind. Okay, let me give you some context to understand better my motivations. So we started to work heavily on predicting JavaScript vulnerabilities. For this, we collected a quite large data set that contains 12,000 JavaScript functions. And we mined various public vulnerability databases to find out if there are some vulnerabilities to be found in these JavaScript programs, and map those vulnerabilities to functions. So we got 12,000 functions. Some of them were vulnerable, so contained some security issues, and the others did not contain such issues. So we had this large database, and we, of course, built some prediction models based on static source code, process metrics, and so on and so forth. So that's the context. But the idea here, or the motivation, is to why not go further one step and do not stop at predicting vulnerable functions. Why not generate possible fixes automatically? So not just predict that this and this JavaScript functions might be vulnerable, but also provide some fixing patches automatically. But for this, it's of course a very hard work because there are some so-called automatic code generators that can generate some fixes to some simple bugs. But the state of the art is actually to generate some one-line fixes. So very complex fixes cannot be handled by this stuff. So first, this paper aims to do the first step towards better understanding the fixes of such security issues. And I wanted to find out how these security fixes look like. Okay, whether do we have a possibility to apply some automatic fix generation methods at all, because if these fixes are typically large or complex, then it's very hard to come up with some automatic solution for generating fixes for them. But if there are some type of issues that might be fixed with a couple of lines with simple and straightforward fixes, then we have a chance to come up with some automatic solution for this. Okay, so that was the main goal of the paper, to analyze this perspective of the collected vulnerability fixes, and we analyzed 361 real-world fixes that we collected in a previous work that contained in this data set we use for building prediction models. Okay, the overall approach is basically a data mining approach. So we mine the GitHub repository and so-called vulnerability databases that contain actual real reported security issues in various systems. And we find the fixing patches in GitHub and we map those together to find out which functions, which are JavaScript functions were affected by a vulnerability fix. Okay, so this is the overall approach how we collected the data set, but in this work, basically what we analyzed are the vulnerability fixing diffs. Okay, so we wanted to check how these vulnerability fixes look like. Okay, whether they affect multiple files, do they add new files, do they add lines or modify lines or delete lines, or do they affect test code and so on. So we wanted to analyze such kind of properties of these fixes. And we wanted to check whether these properties change or are specific to certain types of issues. And for categorization of vulnerabilities, we use these common weakness enumeration, which is a taxonomy for vulnerabilities. So they provide categories like input validation or injection-like issues and so on. So we can use these categories for vulnerabilities. Okay, and briefly about the results. We investigated 3 research questions, and the first one was how the basic properties of vulnerability fixes look like. And what we found is that a fix that fixes some security issues rarely removes any files. Most of the times it modifies some files and adds some files, which is not really surprising. What is a bit more surprising that on average more than 100 lines are added. Okay, so the security fixing patches are quite large in average. And there are significant amount of removed lines as well. And on average, a single security bug fix affects 10 functions, which seems a lot, actually. But that's the numbers. And the second research question was about how these security fixes affect test code, whether a security fix affects test code or not. And what we found is that test code is heavily affected. I mean, most than half of the times, not just code files, code were changed during the security fix, but the developers modified test code as well. So of course, in a much smaller amount. So on average, a couple of tens of lines are added or changed, but many of the cases, test code also changes. So security fixes often comes together with adjusting the tests of the program. And the third research question is about is towards the direction of this possible automatic generation of such fixes. So how frequent are the small changes to real-world vulnerabilities that we can probably generate with some automatic method. And this is the first view. Probably you won't see it too well because the figures are a bit small. But in the x-axis, there are the CWE categories of vulnerabilities. So these are the vulnerability types. And of course, many concrete actual vulnerabilities fall into these types. And the height of the bars represent the average length of the fix for such vulnerabilities. Okay, and of course, we are interested in this lower part. So the CV410 type of vulnerabilities are fixed in 2 lines of code on average. Okay, so these issues can be fixed with very few lines. Okay, there are a couple of other categories that can be fixed with less than 10 lines on average. But as we can see, there are some vulnerability categories where the fixes actually are pretty large, about several hundred lines of code. Of course, we would need to manually check all these security issues to see what might happen here, but that's just an ongoing work. So we actually do it right now as I speak, so it's an ongoing research. The other way we can look at it is again the CWE categories on the x-axis, and actually the orange bars show that how much of the vulnerabilities falling to these categories have 10 lines or less fixes, and the blue bars are those fixes that belong to this category and has more than 10 lines of vulnerability fixes. And as we can see, even though the averages are pretty high, but in almost all the cases, you can see there are certain vulnerabilities that can be fixed with 10 code lines or less. Okay, and actually, the ratio is pretty high. So half of the issues in each category can be fixed with quite a short patch. Okay, so the manual investigation could answer what are the differences in cases where we can fix the similar issue with small number of lines, and what happens when it needs many changed code lines. So it's again very interesting, but there is a hope that we can generate, or at least we can generate for some vulnerabilities, some fixes automatically. Okay, so to wrap up my talk, I just want to repeat that we analyzed 361 real-world vulnerability fixes in JavaScript programs that actually fix a real reported security issue. And we focused on properties of these fixes, like how many lines are added or how complex they are, so that check whether it is feasible or not to think about automatic patch generation. Okay, what we found is that security fixes in JavaScript programs mostly modify existing files. Addition and even removal is quite rare. And the number of lines, additions, and modifications overweight line removals. Of course, a test code is heavily affected, so many of the vulnerability fixes affect test code and not just program code. Okay, and the final thought is that it's very unlikely that we would find a very general solution that can generate automatically fixes for each and every type of issues, each and every situation, because as we saw, there are quite complex, quite large vulnerability fixes. But there is a hope that we can at least tackle a quite large portion of the issues, because in total, half of the fixes affect only 15 lines or less. So half of the vulnerability fixes are actually quite small, quite concise, so we have a hope that we can generate them somehow automatically, and that would be a quite good result to be able to provide automatic solution for half of the found vulnerabilities. Okay, but that's future work, of course, is just a preliminary basic study to see whether it is even feasible or even worthwhile to go into this automatic vulnerability fixing direction. Okay, thank you very much, and questions are welcome.
Any question, please? Thank you so much. Any question, please? So, hello, Peter.
Yes, I'm here.
Yes, yeah. What is the plan of your future work in this one?
Pardon me, can you repeat?
Yeah, what is your future plan in this work?
Future plan, yeah. The future plan is to go on and try out some automatic fix generation methods. So there are some general solutions that use genetic programming or some deep learning based generators. Yeah. So we want to try those solutions, how they work for vulnerabilities, and maybe to find some options how to fine-tune them and make them more appropriate for vulnerability patch generation. So that would be the long-term goal.
Okay, well, I think it is clear to me. In absence of any other question, thank you so much, Peter.
I have some question. May I have? Thank for a nice presentation, Peter. And I want to ask, how do you prevent making or introducing new errors? Because usually, if you fix some errors, you can introduce new ones. And if you do it automatically, without deep checking of the related code, you can simply introduce new errors, and then you don't fix the code but modify it somehow.
Yeah. So the common strategy for checking the feasibility and the goodness of the generated patches is using unit tests. So that would be our first choice. So to select systems that have quite large set of unit tests, and most of the subject systems do have such unit tests at the moment. So we run all the unit tests before the patch generation and see what are the failing and passing unit tests. And the basic criteria would be that if we apply the automatically generated patch, then no unit test should fail that ran before. Okay, so we should not make the system worse. Of course, it will work only if we have enough code coverage with unit tests. So of course, that's the shortcoming. But that's the idea how we should handle to keep up the syntactic and semantic correctness of the system to run the whole unit test before the patch generation and check that we won't make it any tests fail afterwards.
Yes, thank you, Peter.
Thank you.
I will
Thank you.
request to the next presenter. Next presenter is the, okay, I think Akshat is not ready now. Is the Jose Nuno Castro, the Macedo is available in the viewer? A combinator library to disambiguate.
That's me.
Ambiguous grammar.
Can you hear me?
Yes.
Okay, nice. So just 1 second. Okay. I'm trying to present. Okay, is it working?
Yes, it is working perfectly.
Okay, thank you. So I will be talking about Indubio, a combinator library for disambiguation of ambiguous grammars. The slides are full of text. I wasn't sure if the audio quality would be very good, so I included a lot of text to be easy to follow. Okay, so let's start with an introduction. So in the early times of programming languages, their development was accompanied by the development of techniques for recognizing code. So for example, if I write a program, I need another program to interpret it, that is a compiler. So to generate compilers, for example, we need something that reads the code and understands it and transforms it. That is a parser generator. For example, Yak is a very well-known parser generator. There are more, such as Until R, I think. So if we want to write a program, we have to write. If we want to write a programming language, we need a grammar. The grammar specifies how the syntax of programs in our language. So, for example, there is a grammar for C, there is a grammar for Java, for Haskell, etc. So, if the grammar is written in an ambiguous way, that is, if there are different possible interpretations, the parser generator cannot understand it. So the writer of the grammar has to take special care with how they write the grammars. If we want to write an unambiguous grammar, a grammar that has no possible ways to interpret it incorrectly, we need to use disambiguation rules, which are rules which define how the grammar should work when it is ambiguous. There are several disadvantages of these rules. For example, there are only predefined rules. We cannot add new rules that do not exist. The rules are part of the grammar, and they are context-free. So we cannot define rules that behave differently in different contexts. They are not modular. So if we want to change one of these disambiguation rules, we must generate a new parser. And since these rules are they are like a black box, so we can use these rules, but we do not know how they are actually implemented. We just have to trust that the pre-existing rules behave properly. So in this work, we will present an alternate technique in which we use simple combinators that can be composed to create a more complex disambiguation rule. I think it will be easier to understand with examples in the following slides. Our work is available online in this URL. So a bit more background, maybe I talked about it too fast. So if we want to define a programming language, we need to use a grammar. For example, the BNF Backus-Naur form notation is typically the most used. If this grammar is ambiguous, if it is written in a way that can be interpreted in different ways, there are techniques that can interpret it in all possible ways, and then we choose the one we want, which is the generalized LR parsing technique. Yeah. There are also two different ways to parse a program, which is lexer parser and scannerless parsing. The first one is divided in two steps. We first use a lexer and then a parser. It is more efficient, but less. It is also more complex, I mean. And scannerless parsing just processes the text in one step. There is a paper which we must mention in our work, which is Disambiguation Filters for Scannerless Generalized LR Parsers by Van der Brand, which presents some techniques to deal with ambiguity when we're working with generalized LR parsers that are scannerless. And because our work is built upon compilers, not compilers, it is built upon parser generators. We have to use one, so we pick the HA-GLR, which is a GLR parser generator written in Haskell, which is less efficient but more simple to understand and to build upon. We wanted to clearly separate our work from the parser generator itself. Here I will try to first explain this image and then we will work from there. For example, for the mathematical expression 1 plus 2 plus 3, if we have a parser that is trying to read this string 1 plus 2 plus 3 and is trying to understand what it actually means, this image shows two possible interpretations of this expression. One of them places the first sum earlier, and the other one places the second sum earlier in terms of interpretations. So, for example, one of them would, when solving the equation, one of them would calculate 1 plus 2 first, the other one would calculate 2 plus 3. So a parser would not know how to pick which of these trees it would pick. So we need disambiguation filters to tell him how to behave. Because we wanted our work to be as general as possible, we referred in our work to the names of the nodes instead of the symbols. So here, for example, if we want to talk about the plus symbol, we refer to infix expression 2, which is the name of the token, instead of the actual plus symbol. We could change it to be more to use the plus symbol. It would be very easy to do that. So in terms of the filter itself, so here we have these two trees and we want to select which one interests us the most. And we want to associate the sum. Here we can say that if we have an infix expression 2 at our root, at the topmost level, we do not want the child to the right to have an infix expression 2. If we do this, we are telling the filter to reject the tree to the left and to only keep the tree to the right. And thus we remove any ambiguity. We do this in Haskell. Our work is implemented in the Haskell programming language, so maybe the code is not very intuitive. That's why I'm trying to explain using the image. When we have the infix x2 node, we do not want any infix x2 node to the right. Of course, this can be generalized for any symbol. I'm just using a concrete example. The following slides are explaining other filters that we also implement. For example, for priority symbols, the behavior is very similar. So in this case, instead of 1 plus 2 plus 3, we have 1 plus 2 times 3. So this time, when solving the mathematical equation, the results can be different depending on the order. So here the filter is more important. But for priority, we actually the implementation is similar. We say that if the root matches infix expression 1, we do not want any of the childs to have infix expression 2. That is, if we have a multiplication, we do not want below that any sum to be more prioritized. We can talk about reject filters. These ones might be less intuitive than just associating the order of operations. Reject filters are typically used to implement what we call reserved keywords. For example, in most programming languages, we cannot have variables with names like true, false, while, for. All those kinds of reserved keywords cannot be used as variable names. And we have to tell the compiler that this cannot be the case. So to do that, we have a filter that says when we have a node that matches, in this case, a node that matches ID, which stands for identifier. When we have ID identifier, it cannot derive into the string true or the string false. Typically, when parsing x equals true, which these two trees can represent, this true can be understood as either a Boolean value or an identifier, but we want to reject the possibility for it to be an identifier. So what we say is, if there is an ID node, it cannot derive into the string true. The follow filter is probably the most complex to understand of them all. This filter is used to define sequences of values. For example, I think with a practical example, this would be easier to understand. So for one programming language in which the space can be used to separate a sequence of values, this is valid in, for example, in R, the statistical programming language. So let's assume we have here an array with two values, 12 and 3. Because we are working with a scannerless parser, it can understand this as a sequence of 3 numbers, 1, 2, and 3. So we want to specify to our parser that when we have a sequence of values, there must be, we want the longest match for each value. So this filter is also known as the longest match filter. For example, when we have 12, 3, these must be understood as 12 and not as 1, 2. We want to match the 12. That's the longest match. We do this by looking at the 1 and the 2 and trying to understand if there is any value between them. That's what this Haskell code is doing. Finally, there is also the preference filter. This filter cannot be specified using our combinators because this filter does not behave the same way. Each of the previous filters, for them to be implemented, we just have to look at one parse tree and we can say if it is correct or incorrect. So if we have a tree in which the string true is an identifier, we know that's a bad tree and we reject it. The preference filter defines that if we have two possible interpretations that would otherwise be correct, we prefer one of them. So we are comparing different trees. We cannot implement it as a filter for one tree. One example of preference filters being useful is when we have the dangling else problem, which is exemplified here to the right. If we have two if clauses and only one else clause, the else clause can be referent to the first if or the second if.
Jose, please summarize your work in 2 minutes.
Okay, I'm already very close to the finish.
Yeah, please.
Sorry
Thank
for
you.
taking so long. So these filters implement already well-known techniques, but they can be extended, they can be composed, they can be changed however we want. Finally, we can add context-dependent filters which behave differently depending on the situation. For example, we can have a filter that associates some operations to the left until we enter inside an if clause, and then we associate some operations to the right. This is not a practical, useful filter. It is just an example of different contexts being used. So to conclude, we present a technique in which disambiguation rules are first-class citizens. We can combine them, we can develop them and perfect them however we want. We have developed a library of such combinators. It is available online. There are also some examples, and we are currently working on integrating these filters with other works such as BIAC, a tool for generating both a parser and a reflective printer for context-free grammar. Okay.
Thank you so much, Jose. Thank you.
I'm sorry for taking so long.
It's okay. It is 5 minutes still because the other authors are also waiting. No problem. Thank you. Any question, please?
Yes, I have probably not a question but a comment. There are programming languages where the same string can be used at the same line, once as keyword, once as identifier. So some of the filters maybe need some small improvements or extensions.
So one string can be used as an identifier, or? I'm sorry, I didn't catch that.
You can write the same word twice afterwards, once and second, and in one according to context, one it is taken as a keyword, and in the second case it is taken as an identifier.
Okay, because these filters are very low level, and by that I mean we can write however we want the filters. We can probably work around the situation. And that's one of the advantages of this work, because we are able to change the filters however we want. We can always adapt them to new situations.
Okay.
Okay, so thank you so much. I think we have the next presenter. Thank you, Jose, for your presentation.
Thank you so much.
So next one is again, I think the ICCSA 3 is Peter is again going to a study of security vulnerability types in different language. This from hello, Gabal.
Okay, it will be presented by Balázs. Okay.
Okay, Balázs. Please, Balázs, come on.
I'm here. Can you hear me?
Yes. Please, loud. It is very slow.
All right.
Yes.
All right. So I'm going to be presenting a data mining-based study of security vulnerability types and their mitigations in different languages.
Good. You're welcome.
Excuse me.
You're welcome. Continue. Go ahead.
All right. So I would like to start off by establishing some basic terminology I'm going to be using throughout this presentation. CVEs are common vulnerabilities and exposures, basically known issues of larger projects, and CWEs are common weakness enumerations, basically groupings for these CVEs. Our goals with these projects were to find noticeable patterns within programming languages when it comes to, for example, finding or fixing these vulnerabilities, how long these take, how many lines, etc. Also to check if more severe issues get fixed quicker, and to look at if languages have more, look at the most prevalent weaknesses of each language. I would also like to talk a little about why we chose certain languages, especially Scheme or Bitbake. They are not the most well-known. We did so because we thought that less popular languages could provide a nice context for the achievements of more popular ones. Our approach was to create basically a miner that would look for dimensions of CVs and then validate if the dimension is correct or not, and then upload it to a cloud database. For this, we use subtools. One of them is called CV Manager that manages a local database of CVs. Another called GitLog Parser that prepares the Git logs of certain commits for the miner to be able to look through them. Is a more in-depth representation of the software. We start off by the manager downloading the CVA data and then storing it in a local database. Then the GitLog parser is going to gather the logs of each project. Then the miner is going to look through these logs and find if there are CV mentions in them. And if there are, it's going to check with the manager if these mentions are correct, if we have stored these in our local database. If so, it's going to take them as valuable CVs and upload it to a cloud database. As for our results, for the first months, I'm going to show you the time-based ones. So the first graph here is going to show the time elapsed between the first and last mention, the average time elapsed between the first and last mention of a CV. And the second one is going to be the average time elapsed since the publication of a CV and its last mention. This basically shows how quickly certain communities react to each issue. This graph shows the correlation between the severity of CV and the time it takes to fix it. You can see that in most cases it's close to zero and mostly in the negative zone, meaning that it takes less time to fix more severe issues, except in the case of Python and Ruby, where there is compared to the other ones, a large correlation, positive, in fact, meaning that more severe issues get fixed a little bit slower. This is most likely because these are taken more seriously. Our first instinct was to assume that they are more difficult to fix, but we couldn't find any evidence of that. This table shows the most common CWEs for each language. We can see that in some languages there are a lot more variants. For example, in the case of Ruby or JavaScript, whereas in C++, it's very clear that CV119 is the most common. We only took the ones that had a more than 5% presence as to not overcrowd this table. The most common CVs overall were the improper restriction of operations within the bounds of a memory buffer, CV119, improper input validation, CV20, out of bounds reach, CV125, and uncontrolled resource consumption. The appearance of these in languages had a clear relation with the way the languages are used. For example, in the case of Ruby, that can be seen in the top left here, CWE20 and 79 are dominant. More than half of the CWEs are made up of these two. They are both due with improper input validation and neutralization. And that's mostly because in Ruby, mostly web applications are created, and that's the biggest issue. But for example, in the case of Scheme, CWE119 is the most relevant. As for quick and short conclusion, languages have, of course, typical weaknesses. For example, as I mentioned earlier, C++ is most common one is CWE119, also known as the improper restriction of operations, and CV400 is the most typical for Go uncontrolled resource consumption. Knowing this is, in my opinion, extremely useful because one will know, and as for developers and companies equally, because knowing what to look out for and what to write tests for, etc., can speed up the process of fixing them and finding them. I also come to know that CV fix times have a low correlation with their severity. This is mostly due to the fact that CVs get fixed fairly quickly. And as such, it doesn't really matter how severe they are, they are usually the priority. And for the last one, issues might appear later. They could be mentioned again for numerous reasons, and the average fix times especially get affected by this a lot. For example, in the case of Ruby again, there the average fix time is fairly high comparatively because it is common for CVs to get mentioned again later. So yeah, that's pretty much it. If anybody has any questions, feel free.
Sorry, thank you so much. It was a nice presentation.
Thank you.
The topic is also very, very valuable for the community. Any question, please ask. Any question? What are you going to extend for in this work?
We plan on at first and foremost increase the sample size because at first we were working with a very limited sample size, and then look at, for example, especially this last point here, what happens when a CV is mentioned again, why is it mentioned again, why would that happen? We also saw that CVs would be mentioned in different projects. For example, a simple CV that should only be mentioned at one would be mentioned in 5 or so. So why does that happen? What are the consequences of that, etc.?
Okay. Thank you so much.
Thank you.
Is anybody remaining? I think one of the last presenter from today is the Akshat Agrawal is available. Akshat. Hello. Is Akshat available? Hello. Moderator.
Yes, sir.
Is Akshat Agrawal is available?
I don't see him. I don't see anyone from the next presentation, actually.
No, but he is in WhatsApp. He is with me.
Can you repeat his name, please?
Akshat Agrawal.
Okay. I don't see it.
Connection is not there.
No, it's not here. What should we do? We can wait. I see someone trying to connect. So maybe...
Is he connected?
Yeah, he's probably having troubles connecting because I see him disconnected now. Let's see on Riot. Just a second.
Thank you so much. So everybody is present since morning here. Peter is present. Balsaz is also, he presented just now. Jay Pancham, are you still here? Yes. And I can see the Rose line is still since morning. She is with us. Lamaya Sardi is she still around? Off the cam? Akshat. Please share your slides. Don't off your camera, okay? So let us see to each other. Okay. You are still in the. Who is writing?
So probably there is an issue with the connection because I saw the icon of poor connection. So is anyone else okay?
I don't think that there's anybody else because it is already 6:30.
Mm-hmm.
Okay, in absence of, if you have any questions, please ask. Thank you so much, everybody. Again, moderator. There is one announcement that tomorrow morning at 9, I have a keynote speech in another conference. So in the first session, I will not be here, but
Okay.
Itmir will be there, and also J. Pancham will be there. And I'm also allotting my one of my PhD, means already his PhD, Dr. Olorunti will also be there.
Okay.
Okay, so 2-3 guys will be there in my absence. I think you will not find any problem, but I will not be here. I may be in my office, but I will be connected with a Microsoft software for another conference as a keynote speaker, right?
Okay.
And the time is same for the second shift. I will be there. Okay, but I think it is also going to be joined. So thank you. I think tomorrow you will be the same, right?
Yes, I will be the moderator for tomorrow as well.
So in first 1 hour, I will be absent, but remaining time I will be there most probably. Okay. So
Okay.
thank you so much, everybody, and for the today was a hectic day. Majority of the presentations were there. More than 75%, 80% presentation was done. Papers were good, and hope you enjoyed well. Right. Okay.
Thank you, Prof.
Okay. Thank you so much. Nice smiling face.
Thank you.
Let me again take another picture of the screenshot. If please on your camera, please once up last picture. Yes, very thank you. Yes. Who else is still remaining? Yes, Michael. Some Danka Achat has problem. It's okay. I think I should take it. Print screen. It's okay. Thank you. It's very nice picture today. Thank you so much. Okay. Thank you. Bye bye. Good night, everybody.
Thank you. Bye.
Bye, sir.
Bye.
See
you tomorrow.
Bye bye. Lamai, please come tomorrow as well, right?
Sir, may I remind you about the form for evaluation? No, he's gone. Perfect.